Welcome. This is a video webinar presentation on infrared windows, the requirement analysis, installation, verification, and documentation to get started. This is presented by American Infrared Consultants in cooperation with IRISS. American Infrared is based in Arizona with national distribution, service, and training throughout the U.S., its territories, and Canada. We have offices in Arizona and North Carolina to support you before and after the sale. Our commitment is to get the right technology, the right equipment, and the right training in your hands that suits your business and what you need to do. We don't have a cookie-cutter solution for every company. We'll customize it and work with you to get the right solution. So what is an infrared window? A window is used to separate two environments of different pressure, temperature, while allowing light at a specified wavelength to pass between the two. Well, practically speaking, an infrared window lets us look inside an electrical cabinet, motor control center, or any other electrical device while it's under load with minimal PPE and with much greater safety. Here's a sample image from an infrared camera looking through a window into an electrical cabinet. It allows us a safer view of electrical items under load, the critical component. IRISS has several families of infrared viewing windows. This is the VPFR range, or viewing pane, fixed, reinforced. The majority of the products you see there, the one on the left is VPFC, which is a crystal window. The majority of IRISS products are polymer-based. They can be seen through with infrared. They're much safer, have a known transmission rate, and are unbreakable with a lifetime warranty. They do offer a crystal window, though, if your requirements demand it. That's the VPFC, like the one on the left. The windows come in standard 4-inch, 3-inch, and 2-inch widths, or 175 or 50 millimeters. And it's a full size with the full 4 inches of viewing area in the 4-inch window. The CAP series is another one, custom application products, and the CAP V series, which is custom application with a visual window, now comes standard in 6, 12, and 24-inch rectangular sizes. As in the one on the right, they have a viewing pane, a visual viewing pane that is an impact-resistant clear polycarbonate lens, as well as the polymer lens that you look through with infrared. They come with covers for just a portion of it or for the entire window. And as you can see on the left side, they can be made into almost any shape imaginable, fitting onto a curved surface of a large motor, various different sizes and shapes they come in. This is the TPC, Transmissive Panel Cover Series. On the right side, you can see through the honeycomb holes through the polymer on either side of the panel. So why do we use infrared windows? To make it much easier to inspect, and primarily to inspect under load. Even with the PPE on the left, are unable to inspect under a full load. And here's the kind of thing we're trying to avoid by performing regular infrared inspections under load, so we can get a good reading and analysis of our circuits, connections, and gear. So let's get started. Determining IR window requirements. We want to review our facility assets, review our maintenance records to see if we have any problem areas or issues, and prioritize our installation based on vulnerability, cost of lost production, scheduled maintenance, downtime, and just prioritize it to your facility. Locations, timetables, and recommended products suited to your locations and your gear. Of course, we want to seek management approval before proceeding, then order our products, train our installation crew, decide if we're going to do it in-house, farm it out. If you have an electrical subcontractor you use, we can train them, we can train your in-house crew, or you can use a mixture. And plan your schedule. It's all about the location of where to put the windows. You've got certain things in any panel box you want to see that are more critical than others. You may have obstructions on the door itself, inside the panel. Many things to think about when installing an infrared window. Verify your areas are fully prepared. So we'll go through an installation step by step. Want to follow best practices. Recommend all power be removed in the areas you're going to install, and follow your company lockout, tagout procedures and protocols. Want to have your personnel trained and certified before any work gets started. Use proper installation equipment and techniques, and verify and document the install. Just some typical safety gear. Follow whatever practices your facility has in place. Obviously, verify power is off before beginning any procedures. Inspect, detect, correct, and document. So it's a perfect opportunity to do a complete inspection with your eyes and your camera, and take some visual photos of your gear. If you're using the VPFR product, it can only be seen through with infrared, so this will be a good chance to get a visual photo to put beside the infrared photo in your reports for management or off-site personnel. They'll know what they're looking at visually and be able to see the infrared images as well. Little follow-up on that. Take a thermographic reading while you've got it open. If you're able to have it under any sort of load, you'll get a better reading. Perform a visual inspection. You may find things that need to be taken care of. Take your standard visual photos for reference and documentation, and start, if you don't already have it, start an inventory, an asset inventory with visual photos, and have a name for every asset you've got, a name or ID number. A little emphasis on your before inspection. There's something that was found to be loose just from visual observation. Detect and correct any issues, obviously. And one thing, you can't always control where the window needs to be. On the left side, you see it was put right through a warning label. So if you can, don't destroy your warning labels. But if you have to, if it has to go in that one space, be aware you have to reprint them and have them readable, legible, and in the proper places. Some of the tools we're going to need: an electric drill, 3/8 inch minimum, 18 volt cordless or corded, step bit drill bit, because we're going to drill various sizes, 9/32 or 7 millimeter drill bit, cobalt type is recommended, a center punch and hammer or over center punch to get your hole started in the right spot, a deburring tool or a metal working round file to smooth the edges, and a Posidrive screwdriver. The IRISS window products come with Posidrive screws, and they Phillips will strip them. And here's a Greenlee hole punch set with 2, 3, and 4 inch punches, and remember, these are full 2, 3, and 4 inches. They're not conduit size, so you want to get the full size. Give us a call if you need any recommendations or part numbers. tape measure could be handy. Here's a power nibbler. If you're using any of the cap products, the rectangular products, you might be using a nibbler to cut out a panel in a rectangular or square hole. Now we'll move through the procedure. Here's a typical panel cover. And here's the panel on the right. We've got a laser system mounted on a tripod here where we can set out of our way and mark a crosshair laser. Just highlight the breaker, switch, or attachment you want to scan with your infrared. Position the laser. They're all movable, height and laterally, to hit the item you want to look at with the infrared. Here's an example. Got the door over when we're looking at the center of 3 fuses. Then when we shut the door, our laser's still marking exactly where those fuses are behind it. Now we know where to mark our cover. All the IR windows come with a template. Center that on the crosshairs. We know exactly where we're going. Here's the punch. In this case, we were able to take the panel door completely off. We could work in a safer area. Use the step bit for our center hole. The window mounting holes are drilled. Another view of our punch kit and our deburring tools on the bottom right. Done a starter hole here on the left. And there's again another close-up of our punch set. This is for the 3-inch window, punching out the 3-inch hole. Be sure and deburr both the IR window hole and the mounting holes. Touch them up with primer. Reminder about the positive drive screw. And print and install your arc flash warning labels as required. And we also have custom IR window labels, as you can see on the right of the window on the right photograph. You can put almost as much data as you would like in there with the QR code. We'll get to that more in a minute. You can use infrared emissivity labels to put inside the box, and they come in various shapes to help you identify targets. And here's a target data label. This will go on the outside of your panel where you can see it, and you can have whatever information you want for your facility, your asset IDs, or whatever you would like to have. You'll put your transmission rate there and where your targets are. With the QR code in the bottom right, we rent a label printer that lets you print these as well as the QR code, which can contain considerably more information specific to this window and this target and this location. Some of the labeling requirements fall under NFPA. Here's an example from a recent one, 2008. Follow whatever procedures and protocols you're required to follow in labeling. With a label printer custom suited, you can make the labels custom to your facility and your requirements. Little information about arc flash labels. Some samples of labels that can be printed. And again, these can be matched to your assets in your facility. Here we show some on panels. And again, if you have to go through existing ones, you definitely have to reprint them. And by printing them yourselves, you can make sure they're up to date and comply with the latest requirements. Here's a view of the label printer. We have them for sale or for rent. You can print the window target labels, arc flash warning labels, right to know labels. The software will let you create anything you want. Pipe or conduit labels. And a little more about the emissivity labels. They have a 0.95 emissivity to eliminate reflection issues and give you a standard reference. They can be applied to various items inside the cabinets you're looking at and come in various shapes to help target identification. Here's the inspection using a infrared camera, minimal PPE, looking inside the cabinet under load. Here's the window with its protective cover opened on the right. The label tells you what your target is, gives you your positions. So some steps after installation: verify your windows are in the proper locations and you got the sizes you wanted. Install the emissivity labels and exterior target information labels. Reapply power under proper protocol procedures and do your first IR inspection. Now that the windows are installed, you want to document every target location, temperatures, and infrared images, and start building an asset library so you can do trending and look at your assets over time. You can use whatever reporting timelines and practices you've been following in your predictive maintenance program. Here's an example of trend analysis photos as a circuit heats up. These can be done over short periods of time, over month to month, or quarter to quarter, or year to year. You can overlay these images and look at trending data such as this. So you can schedule your downtime. We thank you for your time and interest. Here's our contact information.